Archimedes. You know the name, right? The legendary genius of Syracuse. We all know the stories. His eureka moment in the bath, his work with levers. But what if I told you one of his most incredible inventions has been lost to time? We're talking about a fabled cannon, not powered by gunpowder, but by steam. Yeah, you heard that right. Today, we're going to use some seriously 21st century tech to figure out if this ancient superweapon was the real deal, or just a good story. So, this is the big question. I mean, it sounds like something straight out of a steampunk novel, doesn't it? Could engineers, more than 2,000 years ago, really have figured out how to harness the explosive power of steam and launch a projectile? Well, we're about to find out. All right, to really get this, we got to go back in time. Picture ancient Syracuse, a city under siege during the Hellenistic period. Now, this was an era of incredible scientific discovery right after Alexander the Great, and the city's #1 defense was the mind of one guy, Archimedes. The legends tell of these mind-blowing war machines he built, and among them, whispers of this lost steam-powered siege engine. It would have been a total game-changer in ancient warfare. Now, this is where it gets really cool. This quote just nails what we're doing here. We're taking this ancient, almost mythical idea, and we're putting it to the test with some of the most advanced tools on the planet. It is literally the past colliding with the future. But hold on, before we can even consider if it's possible, we have to talk about the physics. Because, let me tell you, making a steam cannon wasn't just about a clever design. It was a flat-out battle against the laws of nature, pushing the absolute limits of what ancient materials could handle. Everything really hinges on this one principle: high-pressure thermal expansion. Basically, when you superheat water into steam inside a sealed container, you create an insane amount of force. So the problem isn't making the force, it's containing it, without the whole thing just, blowing up. And yeah, this list pretty much sums up the nightmare they were facing. You've got to contain all that pressure. You have to make sure the barrel itself doesn't just rip apart. The material has to survive unimaginable stress. And then, after all that, you still have to launch a projectile in a way you can actually aim. If you fail at any one of these, it's game over. Now look at that number. Just let it sink in. 1,083 degrees Celsius. That's the temperature where copper, the most probable material for this cannon, starts to melt. So you're running a super high-pressure, super high-heat system using a metal that's constantly on the brink of turning back into a puddle. The margin for error? It was basically zero. So if building one for real is probably a bad idea, how do we test the theory? Well, this is where living in the 21st century comes in handy. We don't have to actually forge a cannon. We can build a perfect digital copy and let an AI do all the dangerous work for us. And the solution is honestly so smart. Physical AI simulations. We use these incredibly powerful computer models to create a virtual cannon, and then we put it through hell. A neural network then crunches the data on thousands of possible outcomes. We're talking heat distribution, pressure points, material fatigue, to see what would have happened, all without a single real-world explosion. I love this slide because it lays out the two sides of the story so perfectly. On the one hand, you've got the ancient ingredients, the sheer genius of those Hellenistic engineers, a simple copper barrel and raw steam power. And on the other, you've got our modern toolkit, digital engineering, neural networks, and physics simulations. So how's it actually work? Well, first you create a digital twin that's a perfect one-to-one virtual model of the cannon. Then you simulate the insane physics of that steam explosion inside it. From there, you let the neural network analyze thousands of different scenarios to see what happens. And the whole point of all this, to get a clear, scientifically backed answer. Which brings us to this, the moment of truth. After all the history, the physics, the cutting-edge AI simulations, we finally get to the big reveal. Did the digital cannon fire like a dream, or did it fail spectacularly? Let's just pause here for a second and think about that question again. After everything we've seen, the incredible heat, the mind-boggling pressure, the limits of the materials, could it really have worked? Oh yeah, the answer is a huge, resounding yes. The simulations proved that under the right conditions, a copper-lined steam cannon designed with ancient Greek know-how wasn't just possible, it was plausible. It seems the legend actually has a real basis in science. And the data, well, it speaks for itself. This chart basically summarizes the results from thousands of those simulations. And as you can see, the vast majority of the tests, they ended in a successful, controlled launch. The times the barrel exploded actually pretty low in comparison. This tells us it wasn't some one-in-a-million long shot. This was a viable, repeatable piece of engineering. So why is this a big deal? I mean, it's more than just proving an old story might be true. This kind of discovery actually changes how we think about the intersection of history and technology. So, what's the bottom line here? Well, for starters, we've just put some real scientific weight behind an ancient legend. But more than that, we've shown that AI can be an unbelievable tool for historians. It gives us a whole new level of appreciation for just how ingenious those ancient engineers were. It kind of blurs the line between what was history and what we used to write off as pure fantasy. And I want to really stress this point. This wasn't just some cool computer game. This was, and I'm quoting the researchers here, a rigorous mechanical validation. It gives real scientific proof to the idea that Archimedes' steam cannon could have been very, very real. And that, of course, leaves us with one last, really exciting thought. If we can use AI to prove the steam cannon was possible, what's next? The Antikythera mechanism? The lighthouse of Alexandria? Suddenly, the possibilities are as vast and as exciting as history itself.